Hi everyone, welcome to the series Quant Revision for Cat. Today's topic is time and distance. Time and distance. Speed equals to distance by time. Okay. Now, using this, we have to discuss one concept called proportionality concept. Okay. Proportionality concept. I'll take an example and I'll explain it. Mm, if A travels at 7 by 5th of his original speed, he reaches 20 minutes early to his office. Okay. So if A travels at 7 by 5 of his original speed, he reaches 20 minutes early to his office. Now you have to find the normal time taken by A to reach his office. Like normally, if he's how much time is he taking to reach his office? That is what we have to find. So here, let S be the original speed. S becomes 7 by 5 of S, right? So that means 2 by 5 is the increase. Hmm? We have discussed this concept of n by d and n by n plus d. If you remember, this is the first video which I have posted. So here what happens is time, since speed and time are inversely proportional, when speed increases by 2 by 5, that means time should decrease by 2 by 2 plus 5, which is 7. Okay. Okay. So the decrease in time is 20 minutes. It is given that he came 20 minutes early. So 2 by 7 of original time equals to 20 minutes. Okay. Time equals to 70 minutes. Okay. So here, when distance is constant, speed is inversely proportional to time. That means we can use this n by d and n by n plus d concept. Okay. And then we have another concept. Let's A and B are at two extreme ends of a line. Sorry. So A travels towards B and B travels towards A. So at a point they two meet. Okay. Let M1 be the point. So till M1 till M1 total distance covered by both A and B together is D. Okay. M1 is the first point of intersection. The total distance traveled by A and B is D till M1. Okay. After that, from M1 to M2, that means from first meeting point to second meeting point, the distance traveled by both A and B is 2D. And from M2 to M3, from second meeting point to third meeting point, the distance traveled by both A and B is 2D. Okay. So and so on. This continues. Okay. There is an exception in this concept. The exception is speed of A uh, by speed of B is less than 1. Here the exception is speed of A by speed of B is less than 2. Let if we think the speed of A is greater, okay? Like why can't we apply this when let us take that the speeds are in the ratio 1 is to 7. Can we apply this? No. Why can't we apply this is let us take that uh, same example and we are cut it into 7 parts. Okay. One, two, three, four, five, six. Sorry, 8 parts. Cut it into 8 parts. One, two, three, four, five, six, seven, eight. Okay. So this is the meet M1. So speed of A is 1. Speed of B is 7. So when A travels one part, B travels 1 parts. Okay. So what happens next is when A travels another 1 part, B will travel another 7 parts. Okay. So that means you cannot use this simply. You cannot simply use this. Okay. You cannot simply use this. For this, you have to do it manually only. And then the next topic is, and the next concept is similar to the previous concept. When A and B are moving towards each other, and the speeds are in the the ratio of speeds is less than 2, and for this is only for the meeting point M1. The thing is, here A is traveling from A towards B, and B is traveling from point B towards A. Let this distance be d1, this distance be d2. Since both are going to meet at the same, going to meet at M1, time taken by both A and B to reach M1 is T. Okay. So D1 equals to SA into T. D2 equals to SB into T. Okay. D1 by D2 equals to S1 by S2. And from M1, A reaches from M1, A reaches B in TA seconds. TA seconds. Okay. And B reaches A in TB seconds. Okay. So now D1 equals to speed of B into TB. D2 equals to speed of A into TA. Okay. So after by substituting these values here, we get uh, SA by SB equals to root of TB by TA. This is one important formula, and TB by TA, and T equals to root TA TB. Okay, so this is a good concept which was asked previously during CAT. And another concept we are going to discuss today is relative speed. Let us consider two trains. Okay, there is a train A, and there is another train B, and train A travels this side, and train B travels, just a minute. Train A and train B. Okay. Length of train A is LA. Length of train B is LB. Speed of train A is SA. Speed of train B is SD. the time taken to cross each other, like to completely cross, like this point should cross this point. Okay, for that the time taken equals to, we have to add the lengths LA plus LB. Since both are traveling in the opposite direction, relative speed is SA plus SB. Okay, sorry, SA plus SB. When both are traveling in opposite directions, and if both are traveling in same direction, LA plus LB by relative speed, which is SA minus SB. We are keeping mod because we don't know whether A is greater or B is greater. SA minus SB, same direction. Hmm? Okay, that's it about today's class. In the next video, I will try to discuss about circular tracks and clock. Thank you.